Pythagorean's theorem, you see a squared plus b squared equals c squared a lot. Typically, it's written something like this. Typically, you'll see it like this. A squared plus b squared is equal to c squared. But what is an actual square? What does squaring actually do to the number? It multiplies by itself. But let's do a visual representation of why it's called squared. If it's multiplying by itself, why is it called a square? Well, let's say we have the number 3 squared. Number 3 squared, you have a base of, our base, or otherwise known as a root of 3. And we're going to square it. So we're going to take a square with sides 3, 3, and 3. Do you see how we turn this into a square? Yeah. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay? That is actually why it's called a square, is because you're making squares out of numbers. And the square of 3 is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Why is it called a square root? Well, remember what I said? Do you remember when I said that a square has a root, and the root is the bottom part? Think of a tree, right? What's on the bottom of a tree? Roots. So the root of a square would be the bottom layer. So the square root of 9 would be this bottom layer of 3. So that's why it's called square and square roots. If we were to take a triangle, this is 3, this is 4, and then this is 5. Oh, let me redo it this way. So we have a triangle that's 3, 4, and 5. You guys see this triangle it's making? Well, you can't see it yet. It's not done. Okay. We see a triangle there, right? Well, we know Pythagorean's theorem is a squared. This a squared is going to be 9. No. A squared plus b squared, which is 4 or 16 in this example, is equal to, we know this plus this is equal to 5 squared. This is going to be the biggest one. Two more rows. Yeah. I don't have a pass anymore, I guess. Okay. So let's see if Pythagorean theorem is true. A squared, which was 3, or 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, plus b squared, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 plus 9 is 25. Let's see if this should be then 25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. That's why Pythagorean's theorem works. Yeah? Okay. What did I do now? Oh, let me go. Go. Okay. Okay. Another visual representation of this would be something like this. I like this video because it has extra special water sounds. Okay, I'm going to turn off lights really quick. Okay. In this video, okay. In this video, we have a squared, b squared, and then these two should add up to be c squared. Let's see if that happens. If you listen carefully, there's water sounds. And then there you go. And then these two, this should have the same volume as these two if we turn it on the other way. Okay. You guys want to watch another example? All right, I like this one too. Wow. I don't know. Okay. All right, the first thing we're doing today, this should be glued onto page 6 of your ISN, is the Pythagorean triplet notes. All right, a Pythagorean triple or triplets, they're called the same thing. Well, they're also called triplets. A Pythagorean triple are three positive integers, a, b, and c, that satisfy the Pythagorean theorem. So we have a squared plus b squared is equal to c squared. Basically, these are whole numbers that have no decimals, that form right triangles. So we have this chart with a bunch of blanks. How do you think we figure out what this blank is? We know this is our A, this is our B, this is our C. We have a squared plus b squared equals c squared. 3 plus 3 squared plus 4 squared is equal to c squared. 9 plus 16 is equal to c squared. 25 is equal to c squared. 5 is equal to c. So our first Pythagorean triplet, and the easiest one to memorize, is 3, 4, 5. If you guys notice, what example did I use with those blocks? A 3, 4, 5 one, because I knew it would work. 3, 4, 5 is probably the most popular one. You know what it also works with? 30, 40, 50. 300, 400, 500. It also works with 60, 80, 100 too. Nope. Well, let's see. Let's see if the next one's 11, 12, 13. All right. We have 11 squared, because that's what we think it is, plus 12 squared is equal to 13 squared. 11 squared is 121 plus 141 is equal to 169. Is 1 plus 1 equal to 9? No, so this is definitely not right. Oh, 144, okay. Sorry, 144, okay. 1 plus 5, is that equal to, sorry, 1 plus 4, is that equal to 9? Still not right. Sorry, Jonathan. Good guess, though. Let's figure out what it actually has to be. You want to try it with 10? Okay, we know it's 100 squared plus 144 squared is equal to 169. 0 plus 4 is 9. No, that's not right either. No, he's not. Don't say that. All right, let's actually, we've wasted enough time. Let's actually figure it out. A squared plus b, a squared, which we don't know, plus 12 squared is equal to 13 squared. A squared plus 144 is equal to 169 minus 144. A squared is equal to 25. A is equal to what? So the next Pythagorean triplet is 5, 12, 13. Why are Pythagorean triplets so useful? Well, if we had this shape, this triangle, we know this is a 90-degree angle, this was 3, this was 4, what does this one have to be? 5. 3, 4, 5, 3, 4, 5. What if we had this one? What if we had, what does this one have to be? Has to be 5. That's why that reason right there is why Pythagorean triplets are so useful. It's like a shortcut. Okay, instead of working out, there's one other reason, you use them for one other reason. Instead of working these all out, I'm going to give the last ones to you. It's 7, I think this is 24. I'm going to look them up. Does someone want to come to the board and write them down for me? All right, Blake, come up here. Okay. First one is 7, 24, 25. Oh, I guess. Okay. Next one is 8, 15, 17. 9, 40, 41. 40. 11, 60, 61. 60. And the last one's 15, 20, 112, 113. 15. Thank you, Brianna. Thank you. Okay. So, I honestly only have this top one memorized. And the reason why I have the top one memorized is because that one's by far the easiest one to memorize. 3, 4, 5. What? I think you're talking to yourself right now. Okay. Pythagorean triplets can also be multiples of each other. So for example, it says find the last side. We have 40 and 75. Well, if we look up here, I see 40. Do you see a 75 by either of these? Do you see a 75 on any of these? No. So we know it's some sort of multiple. We have 40 and 75. What can we divide both of these by? 5. We get 8 and 15. Is 8 15 one? Oh, look, so the last side should be 17. Hold up, wait a second. And that says the hypotenuse is 17. The biggest side is 17. We have a triangle that's 40, 75, and then the biggest side is 17. 8, 15, 4, or 17. No. Can that last side really be 17? No. So if we divided these by 5, what do you think we have to do to the 15th? The 7? Multiply it by 5. We end up getting 85. So we have a triangle. Which one's the hypotenuse going to be? The long side, which is going to be 40, 75, or 85? The biggest number, which is 85, 75, 40. So why is this useful? Well, it's instead of using Pythagorean's theorem, which we would have had you 40 squared plus 75 squared equals whatever, and take the square root of that, you could have just used this. Let's do the next one. 14, 50. Well, 14 and 50 are not up there. We can divide both of these by 2. And we get 7 and 25. Is 7 and 25 a Pythagorean triplet? 7, 25. So the last side should be some multiple of 24. What multiple of 24? Well, we divided both sides by 2 twice. So 24 times 2 is 48. So we have us a triangle with 14, 48, and 50 for the hypotenuse. Great job, team. All right, the next thing we're going to do is pretty simple as well. I'll give you guys a couple more seconds to write this down. What's wrong? All right, we're good. All right. Okay. I want you guys to shelf Pythagorean triplets. The next thing we're going to do does not have very much to do with Pythagorean triplets. So, this is the next, this is on page 7. We're doing converse of Pythagorean theorem. Converse of Pythagorean theorem, which is right here, says this. A right triangle can be formed when c squared is equal to a squared plus b squared. What does that look like? That looks like Pythagorean's theorem, like this. We know an acute triangle is formed when c squared is less than a squared plus b squared. And we know a obtuse triangle is formed when c squared is larger than a squared plus b squared. So what are we using this for? We're using this to figure out what type of triangle we have when we're given three sides. So we're giving the sides 5, 12, and 14. What type of triangle is formed? A right triangle, a acute triangle, or an obtuse triangle? Well, the first step is we need to see if this can even make a triangle. Does anyone remember how you can check? Yeah? Should be bigger than the big one. Good job, though. So what's the largest side here? 12. So that's our C. Is 5 plus 4 larger than 12? This is not a triangle. What's the largest side here? 8. Is 6 plus 7 larger than 8? Then this is a triangle. What type of triangle is this? Well, we're going to set it up like this. There's too much idle chatter going on. We have c squared, and I'm writing a blank because we don't know if it's equal to, less than, or greater than. C squared plus is one of those three. A squared plus b squared. We know c is 8, so 8 squared blank. I'm going to call this our A, I'm going to call this our B. It doesn't really matter which one's A and which one's B. Okay. We have 64 blank, 36 plus 49, 64 blank. Add these two together and we get 85. Which way does the alligator mouth go? So 64 is less than 85. When it's less than, it's an acute triangle. Okay, first step, what's the biggest side? Second step, can these form a triangle? Is 3 plus 4 larger than 6? Then we know this is a triangle. Now we can plug it in. Biggest side is 6. 6 squared blank, a squared 3 plus b squared 4. 36 blank 9 plus 16. 36 blank 25. Which way does that alligator mouth go? Towards the 36. So 36 is greater than 25. Look up here. What type of triangle it is it if it's greater than? Obtuse. So no, this is an obtuse triangle. First step. What's our biggest side? That's our C. Is 6 plus 11 larger than 12? So we know this is a triangle. We know we're going to have 12 squared blank 6 squared plus 11 squared. 144 blank 36 plus 121. 144 blank 157. Which way does that alligator mouth go? This way. Or so 144 is less than 157, so that's going to be an acute triangle. Okay? Last thing we're doing today, I'll let you guys finish copying this down. I'm going too fast, I'm sorry. Right, Kelly? No, we already did that. Notes for that. We're going to do a homework quiz on Friday over it. Yep. You can cut it if you want, or just glue it down. Just make sure the notes that you've written on is on top. There's a class behind you, Jonathan. That's Shaklovitz. Okay. So, the last thing we're doing today is we learned 4 new vocab terms. Before you can leave today, you need to write down, you need to update your glossary. Our 4 new things we learned is Pythagorean triple, a right triangle this is formed when, an acute triangle is formed when, and an obtuse triangle is formed when.